Hello everyone, welcome back to Bytes of CSC. So today we will learn about Dijkstra's algorithm. So Dijkstra is basically a greedy algorithm where at each step we will choose that option among the many options which will give us maximum profit, and Dijkstra is generally used to find the shortest path between two nodes in a graph. So in our real world scenario, basically Dijkstra's algorithm is mostly used in networking, where a router computes the distance to other routers in the network using Dijkstra's algorithm. So say you have a network of so many nodes. Each node will contain information about each of its neighbor and the path cost to reach to that neighbor. So now let's get started with the algorithm. So this is the same graph that we will be considering. It contains 5 nodes A, B, C, D, E, and these are the path cost. And as you can see, this is a directed graph. That is, we have a path from A to B, but we do not have a direct path from B to A. So I hope you understand what this graph means. Like, you have a path from A to B, then D has a path to B, whereas B is not connected to D directly, and so on. So here we will be considering that A is the node that is trying to compute its distance to other nodes, that is B, C, D, E in this network. So this is the original Dijkstra's algorithm, where G is the graph, W is the weight matrix which contains the weight or the path cost from reaching two different nodes, and U is going to be the start node. So in our case, this U is A. Now we will be using some sets, like this is the vertex set, which contains all the list of the vertices that are contained in this graph. So we have 5 vertices here, A, B, C, D, E. So we contains all those 5 vertices. And in order to implement this algorithm, we will be needing 2 sets. So one is the S set that contains all the nodes that has already been visited while computing the path cost, and there will be another list V minus S that will contain the nodes which has not yet been visited. So now the first line says that you include this first node or the source node or the first node, whatever you call it, to this path S. So now your S will contain this A and V minus S, that is all the nodes that are present in V but not present in S will be B, C, D and E. Now for each V that belongs to V minus S, which means that in this set we need to compute the distance to each of these nodes, that is distance from A to B, A to C, A to D and A to E. So we will be maintaining a table for that. As you can see, there is a path from A to B which has a path cost of 10 or weight 10 according to this algorithm. So now A has, well, it doesn't matter. So the path cost from A to A will be 0. Now this table is drawn in accordance to A, that is the source node or the start node. Okay. Now from A to B we have a path which costs 10, and from A to C we have a path which costs 12. Now till now there is no path to D or E. So in this case we will be considering that D and E has a path cost of infinity. Now what happens is, while S not equals to V, so we actually start with a loop where we will be choosing a vertex Y from this set V minus S such that dy is minimum. Now in V minus S we have B, C, D and E, and we have path cost B and C, and well, for D and E this is infinite. So the distance dy, I mean in order to consider this line where dy is minimum, that is the distance is minimum, so we have A to B distance minimum among all the possible candidates. So we will be including B here in this set. So this is what is depicted here, like add y to S. So this y in this case is B. So B is added to this set S, and remove y from V minus S. So y does not, y or B does not appear in this V minus S set. Now for all neighbors V, that is the neighbor of y, we need to compute this distance where dv is any neighbor of B in our case. Now B, in this case there are two nodes reachable from B. The neighbors of B are C and E, as you can see here. Now see, the distance from B to C is 2. Now in order to find the distance from A to C from B, we will need to compute the path cost from A to B, that is 10, plus the path cost from B to C, that is 2. That becomes 12. Now, so V, the first V that we consider is C. Now this C, well, as we can see here, dV needs to be minimum of dV, that is the distance that was already there in this A's table, that is in this line of the table. So the distance from A to C, there was a direct path which costed 12. Now there is also another path from A to C via B, and that path cost here is this path cost plus this path cost, which is equals to 12. So we have 12 from both the paths. So the value of dV, or the value of distance from A to C, remains 12, or will be remaining 12. Now we have a path from B to E, and E for now has a path cost. The path cost from A to E is infinite for now. Now in order to find the path cost from E via B via A, path cost to E via B from A, the distance will be 10, and the path cost from B to E is 10. So 10 plus 10, that is equals to 20. Now if we consider this line of code which says that d of V, that is distance to V in our case, will be E. So distance to E is going to be minimum of distance to E and distance of Y, that is Y in our case is B, distance to B plus the path cost between B and E. So this was infinite, and this is going to be 10 plus 10, that is equals to 20. Now we still don't have a path to D, therefore we consider this as infinity. Now next, we have already chosen A, we have already chosen B. Now the possible candidates, that is C, among C, D, E, we need to choose a node that has the least path cost from A. Now the least path cost from A, now since this is already chosen, is 12 in this case. So now we choose C, which is equals to 12. Now we have to consider the neighbors of C. Now see, C has only one neighbor, that is E. Now we have already got a path cost from A to E that costs 20 here. Now coming to this part, now for all V, that is in this case our V will be E, since C has already only one neighbor. So that belongs to neighbor Y, that is C. Do dV, now your V is E, that is distance to E is going to be the minimum of the distance to E and distance to Y, that is C in our case. So in this case it will be 12 plus distance to path cost between C, that is Y, and E. So the path cost between C and E here is 5. So the summation becomes 17. Now the minimum of 20 and 17 will obviously be 17. So now we will be updating the path cost from A to E. Now the new path cost is 17. So now we have already chosen ABC, and the two nodes remaining is D and E. And now D is still infinity because we haven't yet found a path reachable to D, considering the nodes in this S set. So now we move on to the next node. So next we will have to select E because this is path cost infinite and this path cost 17. So we naturally select E. Now E has a path from itself to D. Now in order to find out the path cost from E to D, now let's consider this. So in this case, path cost to E, it will be equals to path cost to E, that is 17. So we write 17 here, plus path cost from E to D, that is equals to 2. So 17 plus 2, which is equals to 19. And the rest will remain the same. Sorry, there is a mistake. This should be D. Okay. So now we have a path cost that is 19, and now all the nodes are already being selected, and the only node remaining in this V minus S set is D. So naturally we select D here, and all the remaining path costs remain unchanged, and this is what the table of your final step of the Dijkstra looks like, because S not equals to V. Now S is equals to V, so the loop is going to stop over here. See, all the nodes in V is already selected in this set S. So that is all about Dijkstra's algorithm. Now we will just need to know two trivia, that Dijkstra's algorithm, in order to implement Dijkstra's algorithm, all the edge weights needs to be positive. Now if you are wondering what this negative edge weight or what is it all about, we will be learning Bellman-Ford algorithm in one of the subsequent lectures, and there I will explain what a negative edge weight means. And then it also has a complexity for this algorithm. This particular algorithm has a complexity of O V square. Now these bars indicate the number of vertices present in the set V. So that square is the complexity of Dijkstra's algorithm. So that is all for today and all about Dijkstra. If you have liked my video, please give me a thumbs up and do share it with your friends. So thank you. Thanks for watching.